Hello everybody, Caveman Math here. I'm back with another video. In this video today I will be explaining polynomials, rational functions, finding the vertex of quadratic functions, dividing polynomials, finding all x-intercepts of polynomials, as well as writing equations for fifth-degree polynomials with real or imaginary roots, as well as graphing polynomials, followed by simplifying these complex functions, as well as graphing these rational expressions, followed by writing down from a graph nonlinear inequalities, as well as rational inequalities. Let's get started. I'm going to basically explain what I'm saying here. Well, this first question is actually not about inequalities and rational functions and quadratics and whatnot. So let's go to the actual questions for now. First, we need to find the vertex. Now, we all know that the vertex is first found by finding the x-coordinate, and the x-coordinate is found as the AOS, which is negative b over 2a. Now, when you find your x, now you have to find your y, right? And your y is actually just y minus b squared over 4a. That is how you find the y portion. Now let's apply that to this question. Negative 4. Negative times negative is positive. So we have 4 over 2. And that's just 2. So our first coordinate is 2. And let's go to the next one. Negative 60. Negative 60 plugged in. We're just going to plug it in right now for now because it's too complicated. We have 16 over 4. Now 16 over 4, that's just 4. So it's just negative 60 minus 4. Plus, that is negative 64. Right. So with these, we conclude that is negative 64. 2 and negative 64. That is the answer for this. Let's go on to the next question. The next question states negative 2x to the power of 2 minus 8x plus 6. How we approach this is the same method. First, we write it down. Negative cancels out, so you already know. 2 and then negative 2. Alright, these go out. We have 8 over negative 4. So 8 over negative 4 is just negative 2. We have our first coordinate down, which is our AOS. And now what we have to do is 6 minus, what is it? Negative 8 squared over 4 times minus 2. Alright, we got to get this down straight. This is going to be positive, so it's going to be 6 minus, and then times, well, I mean, it's still going to be minus, but 64 over 8. And that's still negative. So this is still negative. Negative cancels out. I mean, not really cancels out, doesn't it? No, it actually does cancel out. Yeah, so that would become positive. So it's just 8 divided by 6, 8. So 8, 9, 14. 14. Yes, that is correct. 14. Just to make sure, I'm going to check this in my answer checker so I don't mislead you guys. And as I can see, the vertex of this is indeed 2, negative 2 and 14. So this is correct. Alright, the second one. This one, well, the vertex is kind of just written out. It's this and this. So we actually have to solve it, which is, not solve it, but, turn it into x-intercepts. Actually, no, you can't do that. You can't do that. No, I'm sorry. I'm taking that back. You got to actually FOIL it. So plus 7x, and then negative 5x, and then negative 35. Now what that's going to do is 5, 6, 7, 7x squared plus 2x minus 35. Yes, that is correct. All of that looks nice. Okay. And now what we're going to do is the same thing that we've done with all of these, right? So it's just negative 2 over 2, and it's just negative 1. So it's negative 1. We have negative 1 for the first one. And let's do for the next one, which is going to be negative 35 minus 2 squared over 4. What that gives us is just 4 over 4, and that's 1. And what that does is just it's negative 36. Negative 36. If I plug this into my answer checker right now, which I will, because I want to teach this correctly, when I check it with my answer checker, it says that the vertex is negative 1 and negative 36, which is correct. All right, divide using the best method. Now, my rule of thumb is that if there is no leading coefficient in this dividend, or sorry, not dividend, but divisor, if there's no leading coefficient in the divisor, then you can just use synthetic. And this is kind of my preferred method because it's just really easy. So how synthetic division works is you have your factor, or yeah, that one. I mean, you don't know if it's a factor yet because the remainder is unclear, but you have to solve it. So you put 3 down, which is your first leading coefficient. Then you put 9. Then you put negative 5, which is here. Then you put negative 6. Then you put 2. Right? Now, the first number always gets dragged down to the answer. So it's 3. But now we have to multiply 3 to this divisor. And now that becomes 6. And what's 9 plus 6? 9. 15? Yeah. Yep, it is 15. 15 times 2 is 30. 30, 20, oh, no, sorry, my bad. 25, 25, 50, 54. So that's just 4, so that's just 44. Yeah, 44. That makes sense. And then that's just 80, 88. Yeah. So, and now you just do that, and that's just 90. So our final answer would be 3 to the power of 3, because it's always one exponent number less when you want to write the answer down. So we're going to do that. Plus 15x squared instead of cubed, and then plus 25x plus 44. And now we write our remainder, which is 90. So plus 90 over our divisor, which is x minus 2. Let me answer check this for clarity and see if I got it right. If I plug this into my trusty old answer checker, I will see the best method to divide gives me this answer. 3x to the power, well, it gives me, yes, 3x to the power of 4 plus 9x to the power of 3 minus negative, or is it minus 5x squared minus 6x plus 2 over x minus 2. Now, ladies and gentlemen, this answer is actually correct. However, whenever I put this into an answer checker, like online, it seems to not be, it seems to be something else, but the answer key says otherwise. So I'm just going to stick to the answer key. But yeah, let's keep solving the next ones that are, either division by polynomial, long division, or synthetic. Let's get this one. This one is just 7, you know the drill. 10, 3, 3, negative 3. You bring the 7 down because that's your first number. 7, and now you multiply 7 by 1, it gives you 7. 7, 8, 9, 10. 3, negative 3. Negative 3 times 1, negative 3. Negative 3, 0. 0 times 1, 0. 0. 3. 3 times 1, 3. 0. Our remainder is 0, and when our remainder is 0, that means that x minus 1 is a factor, which is good, right? And this is eventually what we're going to use to find the roots of numbers. Sorry, not numbers, but polynomials. Now let's write this out. 7x to the power of 3 minus 3x to the power of 2. 3x to the power of 2. And because this is 0, we don't actually write it. So we write the next one over. So that's x squared. So that's x. So that's just plus 3. And that is our answer. So that's our answer to that one. Now, list all the x-intercepts of the following polynomials. Now, what we need to do essentially here is, we can actually factor this out one first. So 5x to the power of 2, and then we got, you already know, x to the power of 2 minus 4x plus 4. There we go. We got all of this factored out. We found our first x-intercept, which is this thing. So that thing is actually equal to 0 because it's not an x-intercept. Alright, now let's look at another one. I mean, it is an x-intercept, but it's not, it's just 0. It's just equal to 0. And like, it is 0. The x-intercept is going to be 0. So here, what we're going to do is, you look at it very closely. You're like, okay, let's try guessing and checking, right? X minus, hold up. This is just the same thing. This is just x minus 2 to the power of 2. It's just 2m2. 2m2. But you don't actually write m2 because it just says list all of the following x-intercepts. So you don't mind that part. But yeah, well, it's already settled. Let's do the next one. We got this giant equation. Alright, what am I going to do with this? Can I factor anything out? Let's see. We got 48, 64, 8 times 8, 64, 5 times 6, 8 times 8, 64. I actually kind of need to do some caveman math. Let me think. Never mind, I'm just going to caveman bozo this, but I can just use the rational root theorem, which is just all of those possible roots. So I would, wait, hold on, let me turn up my brightness. Yeah, so it's just plus or minus a bunch of stuff. So plus or minus, let me just 1, 64, 2, 32, 4, 16, and 8. And the reason for this is because rational root theorem relies of the constant over the leading coefficient. So it's just a 1, right? And all of this came out of that. So you just have to find factors of this. And that's essentially what I did. Let's go with one of them and start plugging this in for synthetic division so we can find its roots. We got 4, right? And we put in just normal 4. Let's try it, right? We got 1, we got negative 12, we got 48, we got negative 64. We're going to do this as many times as we need, as long as we find a factor. So 4, and then 4, 6, 7, 8, 9, 10, 11, 8, negative 8, 8, 9, 10, 11, 12, yep, okay, 8 times 4, 32, wait, oh, negative 32, yeah, and then that's just 16, yeah, and then 16 times 4, I forgot what 16 times 4 is, dang, Let's kind of say it. 16 times 4, 24, 4, 2, 4, 5, 6, 6, 64. Okay, that's actually a factor, so 0 zeroes it out. And essentially what we have here is x to the power of 2 minus 8x plus 16, and that's just, let's write out the factor. So x minus 4. There we go. That is the factor. And now what we have to do is x, I think this is x minus, yeah, we can do x minus 4 and x minus 4, because if you multiply them you get x squared and then negative 4x and then negative 4x and then 16 plus 16. Yeah, so that checks out. Alright, we got all that. There's too many. So as you can tell, there is too many numbers, too many words. Too bad I'm not reading them. So essentially what I'd suggest is just combining all of them, being like x minus 4 to the power of 3. Yeah, just leave them like that. This is x equals 4 and 3. Just 3 multiplicities of 4. So let's go on to the next ones. Yeah, we got 3a in it, so 3 over 1, you already know. You got plus or minus 3, 1. Very nice. Let's go for 1. We got 1, we got 5, we got negative 3, and negative 3. Get the 1 down here. Got 1. 1 times 1, 1. 5, 5. What? 2. 2. That does not work. Negative 1. Let's go for it. Negative 3, negative 3. Okay. Negative 1, that's just 4, 4, negative 4 plus 7, negative 7. Nope, that does not work. Let's try 3 this time. So 1, 5, negative 3, negative 3. Got 1 down here. We got 3. We got 5, 6, 8. 8 times 3, you already know. 24, 24, and then it's 2, 1, 21. 21 times 3. I ain't doing all that. Okay. Negative. Let's try that. Negative 3. You already know. 2, 6. Negative 6. Negative 6, 6, 7, 8, 9. That is not going to work. Alright. Let's see what I did wrong. Alright. When we plug this in to the magic man, I realized that I actually didn't solve it right. So let's go for it again. 1, 5, negative 3, negative 3. Bring it down. 1, negative 1. And then you already know, you got the 4, and then you got negative 4. Negative 4, 4, 5, 6, 7, negative 7. Negative 7, that's positive. Wait. This is positive 7. But that's not a factor. Oh, this is positive 1. Oh, my bad. Okay, one more time. We got 1. We got 5. We got 6. 6. We got 3. We got 3. There we go. Okay, so our factor is actually x minus 1. And then we also got x squared plus 6x plus 3. And I can't factor that further. you kind of get it. You get what this is about, right? And essentially here it says write an equation of the fifth degree with 3 real roots. So you could just do x minus 3, x plus 4, x minus 5. Yeah, you just multiply all these. So let's go for this one. X squared plus 4x minus 3x minus 12. Now you just write that down. Plus 1, so plus x minus 12. And then now I multiply that with x minus 5. And now what that gives me is, this is 5th degree polynomial. Huh. Hold up. I'm going to inspect this a little further. So I actually thought of this one, which is x minus 1 times x minus 2 times x minus 3. And then the conjugate of x minus 2 plus x minus 4 plus 2i. And then that just turns into a minus conjugate. And that's how you find an equation with the 5th degree with 3 real roots. Because in reality, it's just 3 roots. So let's just go to graphing a function. So graphing this function, first we need to identify the x-intercepts. X-intercepts. We have 0. We have a negative 3, m3. We have a 4, m2. These are multiplicities. And from this, we also need to count what direction it's going to be facing. So 3 plus 2 plus 1. So 3, 4, 5, 6, 6. That is even. So it's even negative. So even negatives are normally going to be facing down, down. So what you're going to do is you're going to put your x-intercepts down. So you have negative and you have negative 3. And then you go 1, 2, 3, 4. Right? And essentially you're just going to trace the points. So I mean, actually, let me find if there's a what's it called, y-intercept. 0, 0, 3, 0. Okay, 0, and then the y-intercept seems to be what is in it 4 times is 16. Or we okay. This is negative 3, so this is gonna kink up like this. Oh wait, actually I think it's gonna go like 2, and then that's not a good enough kink. Actually, no, because it's gonna go through that x-intercept, isn't it? And then it's gonna bounce. Oop, that does not look good. You gotta draw these really nicely. Wrong one. There we go. That is a negative even graph. And as I plug this in to my answer checker, I will know shortly if I actually graph this correctly. Now let's see. As I check it, graph, yes, it is very well not correct, because it goes here, goes, wow, it goes out of its way. It goes out of its way to do this. So yeah, it kinks here, right, and then that does not kink there. It goes here, right, and then it bounces because there's a root 2 here. on the 4. That's why it bounces. So it needs to bounce. That's a weird graph. I think I drew it wrong. Because it needs to be a little bit more specific. Okay, there we go. That looks better. It's still a down. So we got 2 plus 2, 4. 4 plus 1, 5. So it's, you already know it's odd positive. An odd positive is normally like this. Normally like down up. So now we have to write down our x-intercepts, which are -1, 2, and 1. And what that gives us is our things. Well, but we forgot a very crucial step. -1m2, 2m2, and 1. So -1 is here, 2 is here, 1 is here. Alright, at our -1, we end up, actually wait, let me find a y-intercept for this thing. So if you plug in zeros for all of them, and then you kind of just solve it in your head, you will get a y-intercept that is, let's see, a y-intercept that is 0 and -4. That's our y-intercept. 1, 2, 3, 4. That's a y-intercept. Alright. When I do this now, because this is bounce off, so you go down here, it bounces off, and then it goes through this one, bounces off this one, because that's also a multiplicity of 2. So when it's a multiplicity of 2, you already know that it bounces off, so it needs to bounce off. So if it doesn't, you're doing something wrong. Now, you have to factor these ones. Oh boy. These ones are a bit tricky because, well, you have to factor them. So if you want to factor them, you got to find, you got to factor them. So for this one, honestly, I would just do rational root theorem. I do 4 over 1, and then I do what would I do? I mean, honestly, I could just do -1, -1, 1, -2, -7, or RRT, so there's constant over leading coefficient, -4, it's 1, it's 1, -1, positive, and what that gives me is 3 but negative, that becomes 4, positive, and that's 7, 1, 2, 3, 4, that's 3, but hold the phone, 4, 5, 6, 7, 3, what? Okay, that's a bit awkward, and then I'm doing something wrong. 100% doing something wrong. Let's start from the top. -1, -1, -3, -3, positive 3, 3, 4, 5, 6, 7, 4. There we go. And now that is positive 4, positive? Yeah, positive 4. And that becomes 0. There we go. X squared minus 3x minus 4. And what that kind of gives me is just 4. It's just this. X minus 4 to the power of 2. So we got x plus 1. So my x-intercepts are -1 and 4. Now what I do here, but wait, -4 m2. There we go. So 4m2. 4, and then -1. -1 goes straight through. We have a 4 here. 1, 2, 3, 4. Our degree is odd positive, so you know it's going to go down, up. And what that tells me is it's going to be like, okay, this is -1, right? But -1, boop. Oh, okay. Okay. Actually, -1 is the one with the multiplicity of 2, because the reason for that is when you factor it. Okay, I'll explain on that later. But now, when you move on to simplifying these complex numbers, let's do this example. We have 9 times 3. 9 times 3 is 27. And then 9 times -3 is -3i is -27i. And now that is just positive 9i. Yeah. And that's just -9i squared. Alright, what am I going to do here? Well, I don't know what 27 minus 9 is. Goofy caveman math. Yeah, you already know 27 minus 9, 18. Okay. So this being 18, 18i, but still -27. But this I squared is actually equal to -1. So -1 times negative, that's positive 9. And what happens now is, well, what's 9 plus 27? 9, 36. Yeah, it's just 36 minus 18i. Just to double check, I will actually see if this is right again. Let's say, yes, that is correct. Okay. Now, let me go about solving this one. Yeah. So, we have a, okay, never mind. Actually, you can just do this. 2i. And then we just multiply them. So it's just 2 plus 3i. You multiply by its conjugate. So the conjugate of the denominator is 1 minus 2i. So you multiply them and it's like 1 minus 2i over 1 plus 2i times 1 minus 2i. I know it's like a little complicated, but it gets it done. Yeah. And essentially, if let me think this through a little bit. No, I think I'm doing it right. Yeah. So when you multiply all this extra stuff, you just essentially get 8 minus I over 1 plus 2i, and then 1 minus 2i. And what that gives me, after all that, after simplifying the bottom parts, oh my god, I don't want to simplify all down. Okay, we got 1 minus 4i squared, I think that is. Yeah, and 1 minus 4i, that's just plus, so that's just 5. So this is just 5, or so just 8 minus I over 5. Because this is that. These two multiplied together is 1 minus 4i squared, which turns to 5, and then 8 minus I over 5. So now I just have to separate them. So it's just 8 over 5 plus negative I. Actually, no, not negative I, so it's I over 5. There you go. That's it. Now, let me actually do this next one because these are pretty important. So, the full explanation, x plus 2 plus 6 over x plus 5. The denominator is both of them, both. X plus 2, x plus 5. Now you put the top and multiply, divide. You already know this goes out. You got 6x plus 12. And now you do the same thing with this one. Yeah, that's 8x plus 8 times 5, 40 plus. Now 8 plus 6, 8, 9, 10, 11, 12, 13, 14. You got 14x, and then what is that? Plus 52 over x plus 2 x plus 5. Let me check to see if this is correct, just to validate this answer, because it's very important to be systematic in solving. So when you simplify this, it is going to be 2 by simplify by 2, 7x plus 26. I would have actually never simplified this by 2. It's a good thing that you're error checking with a algorithm that can help you solve, because most of these things I do them on my own, but whenever I want to answer check, I always use an algorithm to make sure I'm doing it correctly, and if the algorithm is bugging, then I'm not going to trust it. So okay, I think I need to cover one more important thing. This is kind of self-explanatory, just like multiplying these by each other. Like you just multiply them, and then you divide out the factors. And then, alright, I'm gonna go to this one. I'm gonna go to the division, because division is mainly important, because this one is 7, but this one's 10 in plus 3, and then this one's swapped. So this is n plus 3 n minus 2 on the numerator instead of the denominator, and then it's multiplication. So I'm going to do this. 7n plus 3 n plus 3 times n minus 2 over 10 n plus 3, and then what is that? N minus 2. Alright, now I gotta solve all this. So when you solve all that, actually no, you don't actually gotta solve all that, do you? Because I got factors in here. I don't need to solve all that. Cross out that. Cross out that. Cross out all that. When you cross out all that, 7 over 10, isn't it? 7 over, let me make sure of this, because I want to make sure that this is correct, because I was about to go the long way, and I don't know if I'm on the long, yeah, I was going a long way. I was going to take it a long way home. So that's 7 over 10. You just cross out all the ones that look the same. Alright, let's go with the next one. This is very important. I think this is where I'm going to stop. So, I mean, actually, no, this and this one. These two lessons are going to be the final ones. So I'm going to solve one example from this one. So the vertical asymptotes are the x-intercepts of the denominator. So there's these, right? So x equals 2 and negative 3. Those are your VAs. the vertical asymptotes. Vertical asymptotes are these things. Yeah. So right. That's -3. Yeah, -3 is our first vertical asymptote here, and then we got 2. 1, 2. This is our 2, right? And now our x-intercept is actually the numerator. So x minus 2, x plus 2. All that gives you is again x minus 2. Oh, this is a struggle, isn't it? This is a struggle. Because you can't be doing that. You can't be doing that. There's gonna be a hole here. Yeah, you can't be doing that. I'm gonna check with this. Be right back. Okay, now I'm back. Since I actually factored this out, there's actually a hole, and it's x minus 2. That's a hole, so hole is x minus 2. You can't be having that, so you gotta take out that vertical asymptote. So now you got this one. You got this intersection, and you got this coming down here. And then that is actually how it's going to be graphed. Wow. How interesting. Now, let me go to here. Actually, you guys need to understand that the horizontal asymptote is defined by the degree of the denominator. So if the numerator degree is greater than the denominator degree, or wait, hold up. Because this is degree 2. If they're the same, I think it's 1. Yeah. If they're the same, it's 1. If the numerator is bigger than the denominator, then I'm going to do a checkup on this. I'll be right back. Guys, now this is what I meant. If the numerator is less than the denominator, then the asymptote is 0. If the numerator is greater than the denominator, if the numerator degree is greater than the denominator, then there's no horizontal asymptote. If they're equal, then it's the leading coefficient. So in our case, the leading coefficient was just 1. So that gives us reason to put it as the HA. Alright, next one, because I got 10% battery and I really got to teach this. So here we actually have no x-intercepts. Because of the top, there's no x on the top. So now we look at the bottom. We factor the bottom, x plus 3, and that's x minus, actually no, x minus 3, x plus 1, because we want this to be negative and that's also to be negative. So right now what we're doing is putting our asymptotes in check. VA equals, yeah, it's just 3 and -1. So we got our 3, we got 1, 2, 3, and we got our -1, which is down here. Okay, now what are we doing with all of that? Now all of that, so if we actually look at this very carefully, we can see that we don't have the x-intercepts and asymptotes. The horizontal asymptote is actually going to be 0, and the reason for that is because according to this law, it says if the numerator is less than the denominator degree, then it is 0. So in our case, our numerator degree is less than the denominator degree, which constitutes an HA of 0. And when that happens is that it cannot intercept it. And I think this just leaves room for a y-intercept. And how you find y-intercepts is actually crazy. So for your y-intercepts, you just plug in, 0. And you plug in 0 for all of this, it's just 5/3. And 5/3 is like, it's like, here, let me show y'all. It's a little below 2. So it's a little below, it's like here. So what you do is you draw a quadratic like this, because there's no x-intercepts, it's not intercepting anything. In case of this one, the numerator is bigger than the denominator, and when the numerator is bigger than the denominator, wait, hold on, what is happening? What? Okay, I need to refresh this because it's being weird. Okay, when the numerator is bigger than the denominator, then that means that there is no horizontal asymptote. So go here, there is no HA. There is x-intercepts, so x-int equals, and let's do an x plus 4 and an x minus 1. Now what happens is you have that. So our x-intercepts are negative 4 and 1, and our VA is negative 3. And what that gives us is, well, let's plot on negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, negative 4. Am I sure about this? I have no idea. Give me a minute. I'm gonna answer check that because I think I factored incorrectly. To be honest with you. No, I'm right. Yeah, I'm right. So this is actually a slant. There's a slant in it. Looks like a slant. Freaking weird. It's a freaking weird one. Looks like a slant, boy. When you do this, it's like there's no horizontal asymptote. Yeah, it's like, yeah, that's weird. Because then that would be like a slant, right? So when it's a slant, I'm guessing it would be like, because there's no predetermined one, and then slapping down a VA, and then slapping down an accent. So it's like, that's what I'm guessing. And well, I need to find a y-intercept for this thing, because when you need to graph these, I think y-intercepts are a good guider. And in this case, the y-intercepts 4 and 3. Now 4 and 3 should be like a 1 and a, like 1.5, like less than 1.5 here. So I would say that's like that. And that's 1. That should not kink like that. I should not kink like that, but that's how it is. And I'm just going to explain this because I'm about the 50-minute mark. I don't want this to be an hour long. So these are found through finding the HA. HA is no in this case because it's not bound. Of VA, we got 2 and negative 3. And then we got down here, we don't have an A. To find the A, we plug in the points here. So as our Y, we have 1 over 2. And as our X, we plug that in, and whatever that equals is our A. In this case, it was negative 2. Now, for these, I think it's really important. These are essentially inequalities, and for inequalities, you need to know if they're included or not. This sign means it's included, and this sign means not included. And the general rule of thumb for this one is factor it out, find the x's, plot it on a number line. When you do that, just fill in for now, and when you know if it's open or not. So you test it, right? So negative 3 came out as true, so it is included, right? And negative 6 came out as false, and this came out as true, right? Because you're plugging these back in here, and if you plug it in, and if it's less or great or equal to 0, then it is included, so it is true. So when you know that, then you know it's true. But now we need to see this in between. If the in between is true, that means it's shaded in between. If the in between is not true, that means it's shaded outside. So for example, if 0 was not true, then this wouldn't be shaded, and rather these sides would be shaded instead of the middle. It's very rare to see an instance of it not being like that. And then what you do is you actually just write the domain like normal. So in this case, this one was outside, so negative infinity, negative 2, and then 3 to infinity. But this one, because it was included, it had brackets around it. So now it's just negative 3 and 6. Right? That's the rule of thumb that you need to know. This is how you write the inequality. Since these are included, have the greater or equal to sign, greater to equal to sign, from the smallest number to the biggest number. That is how you write these. So solve them, like get x's, get the x-intercepts, and then plug them in to make sure they are included or not included. And if they are, like for example, this one is not included, so negative 2 is false, that means it's not included. So that's true, that's true. So that means it goes outwards. And for 3, wait, okay, I need to recheck this. Okay, let's plug in 3, for example. So 2, 3 plus 4, 3 minus 3. Okay, so this 0, 6, 6, 7, 8, 9, 10, 10. 10 is greater than 0. That's true. That's true. That means it is indeed not included. And it is indeed that way. So you already know. And then same goes for these. You just have to find the x-intercepts to be able to plug them in here, and then do the same process of guessing and checking. Thank you for watching this video. I know it has been a long one, but I really appreciate your patronage to my channel. See you guys later. Bye bye.